Okay, so you have 7x plus 1 divided by x minus 4, and you're subtracting 2x plus 21 divided by x minus 4. All right, now in a couple more sections, you're going to be talking about rational equations. So you're going to have this not equation because there's no equal sign, but you're going to have this in an equation. You have to be careful when you see a subtraction. All right, so you're subtracting these fractions, though. The denominators are the same, so now you can write it as one fraction.
And you got to put the second part in parentheses.
Yes. So whenever you're subtracting a fraction where the numerator is more than a monomial, in this case it's a binomial, you got to put that in parentheses so you don't mess up. Because you're not only subtracting 2x, but what else are you subtracting?
The
4. The 4. Oh, I'm sorry, that's 21. 21.
Sorry, it looked like a 4.
It does look like a 4. All right. So this becomes 7x plus 1, subtract in parentheses 2x plus 21, divided by x minus 4. No. Then what's the next step?
Combine like terms.
No. What's the next step?
Distribute.
Distribute the negative 1. Then you combine like terms.
Okay, so I wasn't on the.
So
I wasn't on the one on that page.
7x plus 1 was, and when I use the distributive property, what does this become?
Minus 2x minus 21.
Divided by,
So if we don't put it in parentheses, are you gonna take off?
well, if you don't put a parentheses, what are you going to put in that step? What are you going to write? You got because it has to be mathematically correct. What are you going to write?
How you just wrote it?
Okay, no, that's fine. You can go from here to this step.
Okay, all right. Just
Yeah,
making sure.
no, that's fine. But if you said minus 2x plus 21, you're going to be upset
Yeah.
because I'll be taking points away.
So we got to
All right, so then what's the next step?
combine like terms.
So what do you get?
You get a 5x.
5x minus
Minus
20
20.
over x minus 4.
All right. Am I done? Am I done?
No.
No, you got to factor.
Okay.
So remember, the whole idea with these rational expressions is simplify them as much as
Factor out of
possible.
5
So you can factor out of 5.
means x minus,
So you get 5 times x minus 4 divided by x minus 4. Now what's the next step?
cancel out your like.
Divide out your common factors, and I can divide out which factors.
X minus
minus
4.
4.
When you cross them out, though, what do you need to put in their place?
A 1.
1. So what's the answer?
5 over 1, which is 1, which is 5.
All right, 5. All right, so that's what we talked about last class period. Okay, now we're getting to the point where these denominators are not going to be the same. So remember, in long time ago, when the denominators are not the same and you're adding or subtracting, you got to use what concept?
Lowest common denominator.
Least common denominator. And then you have to write equivalent fractions. So that's where we headed. So that's the next part of this section. So this is still section 7.3. So part A, worksheet part A, deals with what we just did. Part B talks about what we're about to do, where we find the LCD and we write equivalent fractions. So that'll be part B. Okay, so let's look at number 22. All right, 22, you have this. You have 17x divided by 4y to the 5th. You can just put in the corner. Yeah. Uh-huh. And then 2 divided by 8y.
Is it minus?
That's a comma.
Oh.
That's a comma.
So two separate expressions.
2 separate expressions. In the next section, they'll be combined in terms of either adding or subtracting.
Okay.
All right, so you have these two fractions, and the direction says this. The direction says find the least common denominator of those two fractions. So you're going to find the least common denominator.
4y.
All right, so remember in a previous section when we first started talking about factoring, you found the GCF. Here, though, you're trying to find the least the least common denominator, the least common multiple of those two. So in finding the LCD, you look at your coefficients first. And remember, it's the acronym stands for least common denominator, or least common multiple of those terms. What's the least common multiple of 4 and 8? What's the smallest number? Listen to me. What's the smallest number that 4 and 8 go into evenly? Not 2. 4 doesn't go into 8, and 8 doesn't go into and
the
2,
8.
8. 4 goes into 8, and 8 goes into 8. Right? That's your least common multiple of 4 and 8. Okay?
Heard.
All right. You got to make sure you understand this. In a long time ago, when you had 1/4 plus 1/8, you're telling me that your least common denominator was 2? Oh, what's your least common denominator? 8. 8's the least common denominator. It's not 2. And the reason that it's not 2 because 4 doesn't go into 2 evenly. 2 goes into 4 evenly.
Yeah, I'm thinking of factoring. That's what this meant.
Okay? So you gotta remember you're dealing with least common denominators now, least common multiples, not GCF, greatest common factor. This time you're dealing with least common denominator, least common multiple. So the smallest number that 4 and 8 go into is 8. All right, so that's how you talk about the coefficient now. So far my least common denominator is going to be an 8. Now let's talk about the variables. I have y to the 5th, and what's the other one?
Why?
What's the smallest expression that y to the 5th and y go into?
Y to the 5th.
Y to the 5th. So all you do is just take the one with the largest exponent. If you're talking about factoring, what would be the GCF of y to the 5th and y?
Why?
Y. See the difference? One's GCF, one's LCM, least common multiple. So those are two different concepts. So the GCF would be y. The least common multiple, though, is y to the 5th. Okay, so what's the LCD?
8. Y to the 5th.
8y to the 5th. All right. Number 24.
That was it. That's the answer.
That's all they wanted you to do right now. Just find the LCD. That's all they want you to do. Now, in a little while, you're gonna be doing more with it. All right, 24. You have 1 over 6y, comma, 3x divided by 4y plus 12. All right, so let me explain what you're going to do with this. So when finding the when given these rational expressions, either adding or subtracting, you're going to be given expressions where the denominator will look like the second denominator. So the first thing you want to do is factor your denominators and then find the LCD. So before you find the LCD here, is there any denominator? You don't look at your denominator because you're trying to find the LCD, the least common denominator. You don't do anything with the numerator. Can I factor any denominator here?
Yeah, the 4y plus 12.
All right, so good. Tell me what that is.
Factor out a 4.
Uh-huh.
So 4
Y plus 3.
y plus
Okay.
3.
All right, now listen to the words. You got to list your factors. List your factors. In the first denominator, what are my factors?
6 and y.
6 and the other one's y. In the second denominator, what are your factors?
4 and y.
4
plus 3.
and what's the other factor?
Y plus 3.
Y plus 3. So altogether, I have how many factors?
1, 2, 3,
4. 2 of them in the first denominator, and then 2 are in the second denominator. All right, so you have to know what factors are. So the first thing you did was factor the denominators, step 1. Then you kind of determine what your factors are, and then knowing what your factors are, then you can find the least common denominator. Let's start with the coefficients first. What's the coefficient of that first denominator?
6,
What's the coefficient of the second denominator?
4,
What's the smallest number that 6 and 4 go into?
12.
12. So my LCD so far is going to have a coefficient of what?
12.
12. So always deal with the coefficients first. All right, so that takes care of the coefficients. Now let's go back to that first denominator. What's that other factor I see?
Y.
All right, now listen carefully to the words. So you have two denominators, right? So you got to find the LCD. You got to find the smallest expression that those two denominators go into. So that factor we're looking at is a y. So I have a y in that first denominator. Do I have a y in that second denominator?
Yes.
I'm gonna rephrase it. Do I have a y occurring as a factor in that second denominator?
Not by itself.
No. Okay? So I have a y in that first denominator as a factor, but I don't have it occurring as a factor in the second denominator. So how many times does y occur in that first denominator as a factor?
Once.
How many times does it occur in the second denominator as a factor?
None.
None. So I need how many?
One.
1. Y to the first. So far my LCD is 12y. Now let's go to the next factor. I already took care of the 4. The 4 is within that 12. What's the next factor you see?
Y plus 3.
All right, do I have a y plus 3 occurring in that first denominator?
No.
Do I have a y plus 3 occurring in the second denominator?
Yes.
How many times does it occur?
Once.
Okay, so how many do I need? 1. So your LCD is 12y times y plus 3. 12y times y plus 3. So when we add and subtract in the next section, that's going to be your LCD.
Can we do another one?
Yeah.
Number 28. 12 divided by x plus 5, comma, x divided by 4x plus 20. So if you're adding or subtracting, you have to find the least common denominator. But before you find the least common denominator, you have to do what first?
Factor.
Factor the denominators. Can I factor that first denominator?
No.
No.
Can I factor the second denominator?
Yes.
Yes. How do you factor the second denominator?
Factor out of 4.
4 times
4 times x plus
x
5.
plus 5. All right, so I factored. How many factors are in that first denominator? That was a question. Find out what your factors are. What's my factor in that first denominator?
X plus 5.
What are the factors in the second denominator?
4 and then x plus
4,
5.
and the other one's x plus 5. Okay, let's deal with the coefficients first. All right, the only coefficient you should see is a what? The 4.
But you got a 1 in the first.
Yeah, you can think of this as 1 times x plus 5. But what's the smallest number that 1 and that 4 go into?
4.
4. So far my LCD is 4. Okay, now let's look at your factors. My first factor in the denominator, the first denominator is what?
X plus 5.
Okay, how many times do you see it listed at first denominator?
1.
Once.
Okay, how many times is it occurring in the second denominator?
Once.
How many do you need?
1.
One.
1.
So 4x plus 5.
Yes. So 4 times x plus 5. So it kind of makes sense because this denominator, you remember your LCD, the denominator, this denominator that you see here, that factor has to be part of your LCD. And it is. And then 4 has part of your LCD, and the x plus 5 has to be part of your LCD. Now here's the question. Suppose you had this. Suppose it was this. All right, so the only thing I changed, I wrote this example, the only thing I changed was that second x plus 5, that second factor is being raised to the second power. So we go through the process again. In terms of the coefficient, what's your LCD?
4.
4, still 4. Okay, let's talk about the x plus 5. How many times does x plus 5 occur as a factor in the first denominator?
1.
Once.
How many times does it occur in the second denominator?
2.
Twice.
So how many do I need in my LCD?
2.
2. Good.
You add the x plus
So remember, you take the largest exponent. Remember when we did that y to the 5th and that y? It was y to the what? 5th. Okay. All right. Let's look at number 32. So 32, you have 19x plus 5 divided by 4x minus 12, comma. And you have 3 divided by 2x squared minus 12x plus 18. All right. So, and then in the next section, you're going to be adding or subtracting these two things. So the denominators are different. So you're going to write equivalent fractions with the same denominator. The denominator is going to be the LCD.
Factor
So you have to factor first. How do you factor that first denominator?
4.
Take out a 4. 4 times what?
X minus 3.
Okay, now let's talk about the second denominator. What can I do here?
2 binomials.
Now, before you even do that,
Take out the.
factor out a 2. It's important you do your GCF because that's going to be part of your LCD.
Okay, so 2
So 2 times x squared
squared minus
Minus
6x
6x
x
plus 9.
plus 9. Now do what? The 2 binomials. So x squared minus 6x plus 9, how do you factor that? What do y'all think? X minus 3 times x minus 3. Not plus 3, x minus 3. All right, so that's where I'm at. Now notice how it looked. 2 times x minus 3 times x minus 3.
Okay.
Okay, so those are your two denominators you factored. Now let's talk about your LCD. What's the coefficient from the first denominator you see?
4.
What is it from the second?
2
So what's the LCD?
4
4. So far my LCD is going to be a 4. Okay, now let's talk about the next factor that you see. What's the next factor I see in that first denominator?
x minus 3
How many times does it occur?
once.
In your, does that occur anywhere in the second denominator?
Yes.
Yes.
How many times?
Twice.
How many do I need?
2
2.
so 4 parentheses x minus 3 close parentheses 265.
Does that take care of all the factors?
Mm-hmm.
Yes, and go back and check. Okay, go back and check each one. Your factor here is a 4. Will 4 go into this 4 here?
Yes.
Yes. The next factor is x minus 3. You only had 1. Will it go into this one?
Yes.
Yeah. In fact, you have 2 of them. The next one's 2. Will 2 go into this 4?
Yes.
The next one is x minus 3 squared. Do you see this x minus 3, x minus 3 is x minus 3 squared? Will it go into this one?
Yes.
Yeah. There's your LCD. Okay. Remember, you're trying to find the least common denominator. Not just a common denominator, but the least. You want to find the least. All right, that's 32. 36. 36. Don't make it difficult. It's not that difficult.
I hate it when you say that because you're the professor with a degree in this subject and went to school for a long time to get said degree, and you teach, so you don't find it difficult. I'm just saying, no,
Yeah.
seriously.
Well,
no
what am I going to
disrespect,
say?
man,
What am I going to say? Y'all all going to fail this because it is too difficult for you.
Words of motivation right there.
In our money and banking class, she gave us the test back when we were going over them. And she said, now this is the easiest question on the test. Y'all all probably got this one right. And she read the answer and every one of us got it wrong.
All right, so 4 over x squared plus 4x plus 3, comma, 4x minus 2
Plus 4.
divided by x squared plus 10x plus 21.
4x minus 2,
Yeah.
You better do with that factoring.
is it? No, I mean, I'm trying to read.
What's the second denominator?
X squared plus 10x plus 21.
Okay.
All right, so how do you factor that first one?
I'm working on it.
Oh, that's an easy one. Come on.
2 binomials.
Yeah, what is it?
X
X plus Y
plus 1.
Yeah.
X plus
All right. Second denominator, that's an easy one too because the x squared is a coefficient of 1.
So 2 binomials. X and then
X plus 7
X.
times
3.
x plus 3. Okay. All right. So let's find the LCD. Okay, the coefficient, remember I always said talk about the coefficient first. Well, the coefficient here, if you think about it, those are just ones right here. See this? So I wouldn't even worry about coefficient because you really don't see any occurring as a factor except that 1. Now let's go by the next factor that you see in that first denominator. What's the next factor you see? Come on. X plus 1. Okay. So let's talk about x plus 1. How many times does x plus 1 occur in the first denominator?
Once.
How many times does it occur in the second denominator?
None.
None. So how many do I need?
One.
1. Okay. Now let's talk about the next factor you see. What's the next factor you see? X plus 3. How many times does x plus 3 occur in that first?
One.
How many times occur in the second?
One.
So 1 and 1. How many do I need?
One.
1. Okay? 1. Now don't do 2. Now 2 is a common factor, but it's not the least. You want the least. So the least is just 1. If I say 1 and 2, then you would say what?
2.
2. You take the one with the largest number, the largest exponent. But 1 and 1, that's the same. So you say only what? 1. 1 and 0, you say what? 1. Okay. So x plus 3. What's the next factor you say? Am I done with all the factors?
No.
No, because I also see an x plus 7. How many times does x plus 7 occur in that first denominator?
None.
None, so that's 0. How many times occur in the second?
One.
0 and 1, what do you use?
One.
1.
So x plus 1 times x plus 3 times x plus 7.
Yeah, so that's your LCD.
Seriously.
All right. 38. Too much of a what?
Too much sugar for a dime.
What'd she say?
That was some Zachary thing, you know.
That's some back country.
I have no idea what you said.
Probably in your best interest to not know.
Probably. 4x squared plus 5x plus 1, comma, 5 divided by 3x squared minus 2x minus 1. 4x squared plus 5x plus 1.
Squared minus 2x.
3x squared minus 2x minus 1.
All right. Start with some factoring.
All right, so factor the first one. Yeah, 4x and x. 2x and 2x won't work. So 4x and x, 1 and 1, right? Last sign's positive. They're both the same. The middle sign. All right, so 4x plus 1 times x plus 1.
What was it? 4x plus 1.
Times x plus 1.
All right, next one. 3x plus 1, x minus 1. Let's see. Yep, that'll work. All right. Now let's find the LCD. In terms of coefficients, that's just 1, right?
Yeah.
Okay. What's the first factor you see, though?
4x plus 1.
So you have 1, and then in the other one you have 0. So how many do you need?
1.
What's the next one you see?
X plus 1.
Plus 1.
So you have 1 and 0. You need how many?
1.
Okay. Next factor?
3x plus 1.
0, 1. How many do you need?
1.
Next factor?
X minus 1.
0, 1. You need
1.
Now, when we get into the section where you start adding, subtracting, your LCD will not look like that. It will either be 2 binomials, mostly. Okay?
So if we
You're not going to have any with 4 binomials.
So if we get it all the way down to that, we can, and all of them are different, and we obviously have to go with at least one. Because it's like that, we need at least one for the least common denominator. We could pretty much just see from then on, okay,
Yeah,
it's all 4 of these, and just,
right.
okay.
The only you just got to be careful with the exponents. So if you had this, let's say your denominator, whatever the numerator is, let's say your denominator is 4x plus 1 times x plus 1 squared, comma, and then let's say this one is x plus 2 times x plus 1 to the 5th, okay? What will be the LCD? You have 4x plus 1. How many do you need?
1.
Okay. The next one is x plus 1. How many do you need?
1 or 2.
Nope. You only need 2. How many do you need?
5.
You need 5 of them.
Oh,
Because it's got that.
You have 2
5.
here. You have 5 here. You need how many?
Okay, well, I couldn't read that from here.
X plus 1.
You're
equals 10.
sitting right there.
I know, but.
Okay.
You want to wear these?
I probably do. Are they any good?
Okay, so
And the next one you see is what?
X plus 2.
No, but you'll see if that was the case.
Okay.
Okay. All right. So every factor that you see has to be part of your LCD. The question is, how many do you need? That's the question.
Or-
Okay. Now this one was easy because all these exponents were what to begin with when you factored? They're all ones.
Mm-hmm.
So when you factor, each of those factors has to be in your LCD. The question is, how many do you need? And that's where these exponents come into play.
I just have a question about the way the way you wrote it. Obviously, you have the X plus 2 after the X plus 1.
Does not matter. Multiplication is commutative.
Okay.
The order in which you multiply does not matter. So you could put x plus 2 first if you wanted to.
Okay.
Does not matter. Now again, when we do the next section where we add and subtract, it's not the LCD is not going to be that complicated. It's complicated here because you're not doing anything else to it.
Sure.
That's it. Okay, now there's one more we need to look at. Well, actually two more. Let's do this one, number 40. Okay, in 40 you have 5 divided by x squared minus 25, comma, and then x plus 9 divided by 3x cubed minus 15x squared. All right. How do you factor that first denominator?
X plus 5, X minus 5.
The difference of two squares. All right, so that's the first one. X plus 5, x minus 5. How do you factor that second denominator? What's the GCF?
3x squared.
3x squared times? Yep. All right, so that's where we're at. So we factored. All right, now let's talk about the GCF. Start with the coefficients first. What's going to be the coefficient of your GCF?
3.
3. Y'all agree? Okay. 3. So the LCD, 3. I think I may have said GCF. I'm in the LCD. The coefficient of the least common denominator. Okay, now let's talk about the first factor that you see. I'm going to leave some space in part of it just to come back and show you something. X minus 5, right?
Mm-hmm.
How many x minus 5s do I need in the LCD?
1.
Yeah, because you have 1 and 1, so how many do you need?
1.
Just 1. What's the next factor you see?
X plus 5.
How many in the first?
1.
How many in the second?
1.
How many do you need?
1.
Okay. Now let's go to the second denominator. What's the only thing I hadn't talked about in the second?
The X
squared.
squared.
The x squared.
That was left.
So the x. How many? So factor x. How many x's are in that second denominator?
2.
2. How many in the first? None. So how many do I need?
2.
2.
So do you put that back?
Okay. So the way to write now, you can leave the answer like this, no
Put it
big
after
deal.
3.
But we tend to put the monomial factors in front of the binomial factors. So you could write it as 3x squared times x minus 5 times x plus 5. All right, that's how we tend to prefer to write it. But either one's fine. You can put the x squared at the end.
3x squared looks more natural.
It does. All right. Now let's do number 34. 34. Okay, so in 34, we need this will be a little confusing for some of you. You have 2x plus 5 divided by 3x minus 7, comma, 5 divided by 7 minus 3x.
Oh, it's
the
opposite.
All right. Do not say that the LCD is 3x minus 7 times 7 minus 3x. That is not the LCD. This is incorrect.
So I take it there's going to be a negative 1 something in here.
Yeah, it's got to be.
Okay, that's incorrect. You have to recognize that those two denominators are opposites, and you can't factor them like we normally think of factoring, but we do know their opposites, right? Okay, so that means that one of those I can factor out a -1. It does not matter which one. Okay, so I'm going to do it both ways. So if you factor out the -1 from that first denominator, I want to show you what you're going to end up with. You get -1 times
3x minus 7.
no. -1 times
3x.
what is 3x.
Oh, okay, you're just saying.
Negative
A -3x. -1 times what's a -7?
A positive.
All right, but do y'all agree, though? I can write this as -1 times 7 minus 3x. Is this the same as this? Yes or no?
Oh, wait a minute.
No.
No.
Why not? What's -1 times 7?
Negative.
-7. What's -1 times -3x?
Plus.
Positive 3x. Why do you tell me it's not the same?
You were waiting on that. No.
It's,
I call trickery.
Why do you tell me it's not the
it
same?
screwed us up because normally you don't flip around things around a subtraction side.
So you're telling me that 3 minus 6 is not the same as -6 plus 3?
Oh, okay. That's where it threw me. Okay. I understand now.
All right. Now, you're probably thinking of a subtraction not being commutative. That is true. So 3 minus 6 is not the same as 6 minus 3. That's a true statement. But this is a true statement, as long as you keep the signs with
It's the
where they need to be.
negative.
Okay. Now, listen carefully. So if you factor out the -1 from the first one, and remember this -1, see where it's in the denominator? We can bring it to the numerator if we want to. Okay? Now listen carefully. So your GCF, don't include -1 in GCF because I can put the -1 with the numerator. So don't include the -1. So look at this now. 7 minus 3x, 7 minus 3x. What's your GCF? I'm sorry, I keep saying GCF. I mean
LCD.
LCD.
Minus 3x.
7 minus 3x. Right? So that's one possible answer for your LCD. So your LCD is 7 minus 3x. Now, let's do this.
Do the other side.
What if I were to have done the -1 from the other denominator?
It would wind up being 3x minus 7.
Yes. So instead of factoring out the -1 from the first denominator, factor out the -1 from the second. So that's -1 times what?
3x minus 7.
Minus 7. So cover up the -1. And what do you notice about those two denominators?
Your LCD.
They're the same. So what's your LCD?
3x minus 7.
So either one is the correct answer. So your LCD is either 7 minus 3x or what?
3x.
3x minus 7. 7 minus 3x or 3x minus 7. That's a little bit more challenging to deal with. But don't forget, but you're going to have opposites at times when you're adding and subtracting. Okay? So in the next section, we're going to do one where there are opposites to show you what to do. It's not that bad, but it is a little bit more challenging. All right. Now on the worksheet that deals with this, I think I didn't put any opposites on there, but the next section there will be, so we have to talk about opposites again. Part B. This is what section, 7.3? So let's see. No, I didn't put any opposites on this one. On the worksheet part B, there aren't any opposites. But you are going to need them for the next section, so we'll come back to it. Okay, so that takes care of the part B. Okay, so we're gonna do the worksheet for. We still have a couple more things in this section, and that's gonna be part of your part C. So let me go ahead and do this. I'm going to pause this. In a previous course, you had something like this. You had, let's say you had 3, 6 is equal to, and you want to write an equivalent fraction for 3, 6 that's equivalent to some fraction with a denominator, let's say 24. Okay? And so what did you do to find out what needs to be that numerator, that second fraction?
You multiplied however many it would take from the bottom denominator to equal 24, and then you multiply that by the top
All
numerator.
right,
or the
so
first
so you
fraction.
basically said 6 times what is 24?
4.
4. And what you do to the denominator, you have to do to the numerator to keep it equivalent. So 3 times 4 is 12. Okay, that's the idea you're going to use with the variables, with those expressions. So you're going to be writing equivalent fractions. So notice you went from here to here. That's called an equivalent fraction, equivalent fractions, equivalent fractions. All right. Okay, so let's look at 42. So it'll be the same idea you're going to use. And that's taking us to the next section, because that's what you have to do to add or subtract fractions with unlike denominators. It's all this process right here. Okay, 42, you have 3 divided by 9y to the 5th. Now listen carefully. So you want to write an equivalent fraction that has this denominator. And here's the denominator you want. 70,
What page is this? I'm sorry.
this is 470. So you want to rewrite this fraction
72.
so that it has a denominator 72 y to the 9th. All right, it's not that difficult. 9 times what is 72?
8.
So what I do to this, so I got to multiply the denominator by 8 and I have to multiply the numerator by 8. So that takes care of the 8. Y to the 5th times what is y to the 9th?
Oh, y to the fourth.
Y to the 4th.
Okay, so you just multiply the top.
Okay,
by
you're writing
y
equivalent
to the fourth.
fractions. That's all you're doing, just like you did in the previous course. All right, now, what's the numerator now? So in other words, look, I'm circling this. This is my numerator, but it needs to go here.
24.
Multiplied, though.
24y to the 4th.
24y to the 4th, and there's your answer. That's what you do.
That wasn't too bad.
That's how you write equivalent fractions. What do you need to multiply the denominator by to get what you want?
Oh, wait, there's more.
There's always more.
Yeah.
All right.
That's definitely.
Let's look at 44. So in 44, you have 5 divided by 4y squared x. All right, so that's my fraction. I want to write an equivalent fraction that has this denominator though.
Okay.
32
2.
y cubed x squared. So what do I need to multiply the numerator and denominator that first fraction to get that denominator? 8
Y,
y,
X.
Yeah,
X.
8yx.
because look, 8 times 4 is what? Y times y squared is x times x is, all right, but what I do to the denominator, I have to do to the
Right.
numerator.
50YX.
And what
40.
40.
40?
And whatever this product is what you put here.
Yeah.
So it's what, 40yx
Yes, sir.
or 40xy? We tend to put in alphabetical order.
40YX.
It doesn't matter, 40yx or 40xy.
Excuse
Okay.
me. Thank you.
$48. All right, 48, you have 5 plus y divided by 2x squared plus 10 equal. All right, now you want the denominator to be 4 times x squared plus 5. That's what you want. So you want that to be the denominator. All right, don't say anything yet. Think about, what do you think you may need to do first? Factor that denominator, that first denominator. So well, how can you factor that first denominator?
2.
Factor out the 2. So when you factor out the 2, that's what you have, 2 times x plus 5. So your first denominator is 2 times x plus 5, but what do I want?
Plus 2x
Four.
squared.
4 times x squared plus 5.
Squared plus 5.
So what's the only thing I need to multiply that first fraction by?
2.
2 is the only thing. So you say times 2 times 2. Now,
Wait, what?
What?
Lost me.
2 times 2 is 4.
Oh, okay.
Okay, now that I'm going to, since I'm done with multiplying, I'm going to circle this right here, and that was 5 plus y. I'm going to circle that, and there are two ways you can write this. You can write it as in factored form, so in other words, you can write it as 2 times 5 plus y. Okay? See what I did? Or you could have distributed. Or in other words, you could have said r 10 plus 2y. Does not matter. Okay? Does not matter.
Which one do you like better?
It doesn't matter. Since the denominator is in factored, I would have probably left the numerator in factored form. All right, but notice what you have to do. You had to factor that denominator. Okay?
It's a matter of recognizing that whenever you come across it.
All right, 50. 50. You have 5x, and my denominator is x cubed plus 2x squared minus 3x. And you want to write an equivalent fraction that has this denominator. Now listen carefully. X times x minus 1 times x minus 5 times x plus 3 times x plus 7 times
boy.
x plus 6.
Hey, Aaron.
I was about to say, all right, end of chapter. Okay. You want a lot.
All right, so what do you have to do first, though?
I'm sure you gotta do some factoring somewhere.
Somewhere, there's only one place.
Factor the first denominator.
That first denominator. So how do you
So-
factor that first denominator?
X times x squared plus 2x minus 3.
Okay. What else can you do? Yep, factor that trinomial to two binomials. XX, 3, 1. Now notice 3 is negative, so one's positive, one's negative. Which one's going to be the negative?
X plus 3, X minus 1.
Yep, x plus 3, x minus 1. Okay, so that's where we're at. All right. Now, since there are a lot of factors listed on that second denominator, here's what I would do. So notice I have an x, right? Right here. This is what I have. And that's what I want. So I don't need to do anything with that x. I have x plus 3. Do I have an x plus 3 in what I want?
Yeah.
Yes. So I'm going to underline it. I have an x minus 1. Do I have an x minus 1?
Yes.
Okay, was the only thing that's missing.
X minus 5.
All right. So you're going to say times x minus 5, and then times x minus 5.
5x minus 5.
All right. So this is, I'm going to circle just to remind me that needs to be put here, but always put the monomial part first.
Does that mean 5x squared minus 5?
No, just say 5x times what?
No, I'm talking at the top.
What now?
5x times X minus 5.
5x times x minus 5. Where are you getting 5x squared from?
Somehow for the numerator on the second side.
Oh, it's just 5x times x minus 5. Why would you say 5x squared?
Okay, you're putting it in parentheses. Okay.
Now, if you want to distribute, you would say 5x squared minus
Yeah,
25x.
That's what I was getting.
But I would just leave it as 5x times x minus 5. See, the denominator is already in factor form. Just leave the numerator in factor form. It doesn't matter, though. You can distribute or leave it as 5x times x minus 5. Does not matter.
Okay.
Now, when you do my math lab, if for some reason that you put it as 5x times x minus 5, you still get credit. But if they mark it wrong, then go ahead and distribute. Just go ahead and distribute. All right. So any questions? This that's what. So the first part of part C is what we just did. Okay. Now when we see where it says answer the numerator, just tell me what the numerators. Just put the answer that goes in the numerator right here. Okay. All right. Okay. Now that takes care. I'm not sure why I did this. Okay. So this part here, though. Oh, okay. So that's from last. Okay. So this right here, the denominators are the same, right?
Mm-hmm.
All right, so that was from the last
That's a-
class period.
No, it isn't.
They're the same. They're all the same.
I know. I'm fine with that, with that.
Yeah, So remember the part A I gave you is just like this. So part C also includes some of part A.
Okay.
So the addition should be the easy part. Is the subtraction we have to be careful. Remember?
Mhm.
Use the parentheses.
All right. Yeah. So and then you would have to do what to the denominator?
The denominator
You have to factor and then yeah. I mean the denominator stays. Okay. So all right, guys. So if you had I don't know if I did 14, but let's do 13. So if you have 13, this is number 13. So you're already forgetting some things that was needed for the second part of the part C. So at 13, you have 2x plus 3 divided by x squared minus x minus 30 minus x minus 2 divided by x squared minus x minus 30. So this is a review for that part A. And it's also in part C. So all I did was I put some more problems on part A on part C. So what are you going to do here?
2x.
You're going to combine them as one fraction because the denominators are
Right.
the same. So you're going to say 2x
Use
plus
the
3
parentheses on the second.
minus, now you don't have to put parentheses. She did not want to put parentheses. If she didn't want to put parentheses, then she better say 2x plus 3 minus
Minus
x
plus 2.
plus 2. Okay.
Yeah, let's do it.
And the denominator is x squared minus x minus 30. Now let's get rid of the parentheses. You would get 2x plus 3 minus x plus 2 divided by x squared minus x minus 30. What's the next step?
Combine like terms.
Okay, what's the numerator?
X plus 5.
Divided by x squared. Well, let's go ahead. Yeah, okay, I'll put it as x squared minus x minus 30. Now, is that the answer?
X plus.
No.
No, because what are you supposed to, the directions will say simplify. So you got to simplify your answer as much as possible.
Factor the bottom.
You got to factor the denominator, see if any factors can reduce out. So how do you factor the denominator?
2 binomials,
Two binomials,
and 6 to 5.
6 and 5, so x minus 6, x plus 5. All right, what's the answer?
1 over
1
x
over
minus
x
6.
minus 6, not x minus
Yeah,
6.
because you got to factor out the.
It's 1 over. So
Yeah,
remember,
that's
you
fine.
got to put ones in their places. So you'll see the numerator is a 1.
X minus 6.
Okay. All right. And so that was what I was trying to get you to do in number 4, right here. So once you get to that denominator, we write as one fraction. You still have to factor the denominator and then reduce any common factors. All right. So that's part C.